Hello everyone, I'm Ian, and today we are going to blink an LED with Rust. Again. But this time we're doing it on an ESP32, and that's cool. An ESP32 is a microcontroller, just like the Arduino Nano we used in the last video. At face value, it's capable of a lot of the same things. It can get information from sensors, buttons, knobs, and it can interact with its environment using LEDs, motors, actuators, cannons. Okay, I don't know how to do the cannons thing yet, but stay tuned. There are a few important differences here, and without going too far into the weeds, the ESP32 has a faster processor with dual cores, which allows you to multi-thread your programs. It also has Wi-Fi and Bluetooth, which make it especially useful for IoT devices. Similar to the Arduino Nano, it is inexpensive at about $10 and is well supported by the Rust community. So with all that extra processing power, Wi-Fi, and peripherals, this board is just begging to run complex software. We're going to blink an LED instead. But we're going to do it with Rust, so when we're ready to build more sophisticated projects, we have experience with the best tools available for managing complexity. If you're going to follow along, you will need an ESP32 dev board. These come in several variants. The most important distinction is going to be whether your board is the Extensa architecture or a RISC-V architecture. The second bit of information you're going to need is the actual variant of your board, and you can probably find this printed on the top of your board if you either have really good eyes or a magnifying glass or something. Ooh, kind of. Get the light to hit it just right there. I have no idea if you can see that or not, but it says ESP32 WROOM32. So I have the W Room 32 board. You will also need a USB cable and a computer running Ubuntu. If your ESP32 has an onboard LED, you don't need anything else to make this circuit work. If you don't have that LED, like my board has no onboard LED, you will need a breadboard, some DuPont wires, a 5-volt LED, and a resistor in the 100 to 300 ohm range. Before we get started, a quick word about the standard library. Almost all Rust applications that run on desktops and servers utilize what is called the standard library. This is the core library that ships with Rust and provides a lot of really useful functionality. Things like vectors, strings, the result type, the print line macro, and more. So we definitely want all of that when we're coding on our microcontroller, right? Not necessarily. First of all, the functionality in the standard library needs to be implemented separately for every class of processors you want to run it on. So if you happen to be developing on a board that doesn't have a standard library implementation already, and you don't feel like or are not capable of developing your own, there are no options. The decision is made for you. You cannot use it. But for boards like our ESP32, where it has been implemented, you still may prefer to omit it if either it doesn't provide the functionality that you need, or just doesn't fit your use case, or maybe the bloat of the standard library implementation is not worth it. You're very space constrained for some reason. But for us, it's definitely worth it. Using the standard library will make your life a lot easier. We are going to be using the ESP-IDF family of crates to provide our standard library, and they are lovingly maintained by the ESP-RS organization. Thank you guys so much for the work you do and for making our lives a lot easier. So let's get to it. I am starting from a fresh install of Ubuntu 24.04.2 desktop. Since we are going to be programming our board using Rust, we need to install the Rust toolchain on our system. The best way to do this is using the very convenient RustUp tool, and Ubuntu makes installing this tool very easy. All the commands that I use in this video are available in the show notes if you want to copy paste them from there into your environment. Next, we will install the nightly Rust toolchain. And then a lot of dependencies. And then we will install ESP up, a tool that helps set up our system with the ESP toolchain. Now we need to add the cargo binary directory to our path so we can invoke ESP up. Now we need to have ESP up install the toolchain for espressive chips. In order to use the espressive Rust ecosystem that was installed during the last step, we need to set up some environment variables. This command needs to be run in every shell before building any projects. Since that sounds annoying, I'm going to dump the contents of this file into my .bashrc file so that it is sourced automatically with every new shell. Install the linker proxy. Install ESP to flash the project onto our board. Next, we need to install cargo generate, which will help set up our project. Now let's generate our project. Now this very handsome interface pops up and gives us some options about how to set up our project. First thing, project name. I'm going to call it Blink. I know that my board is just a standard ESP32, but if your board is one of these other variants, please select it now. And because our task today is very simple, just to manipulate one of the GPIO pins, we do not need to configure any advanced options. Now we need to install VS Code so we can interact with the project. Now let's open VS Code and have a look around. Just like in our Arduino Nano project, there's a lot in this directory. It's really not important to understand the ins and outs of everything that's going on in here, but your project code will live in main.rs. This code comes with some helpful comments. Line 4 should be in every project that uses ESP-IDF sys in order for it to work properly. And to use logging, we need line 7. By default, this project prints hello world, and that's not what we need. So let's remove that line. In order to flash our LED, we need to set the value of one of the GPIO pins from high to low and back and forth. So those GPIO pins are defined as peripherals. So we need to take ownership of those peripherals. And specifically, we're going to be interacting with the pins. Specifically, we're going to be interacting with GPIO pin 2. So we need a reference to that. Now that we have access to our pin, let's create an endless loop and toggle that LED from high to low every half second or so. I'm pretty sure I'm missing some imports here, so let's have the Rust compiler tell me what those are. The compiler will not tell you about missing imports if you don't save your file. So I'm going to copy in those imports. Save my file, which is very important. And let's check it again. A lot of you are probably thinking this is a very tedious way of getting feedback from the Rust compiler about your code, and that's true. Using the Rust analyzer would be a much more efficient way to do this, but in the interest of installing as few extraneous tools as possible, to keep the learning curve as shallow as possible, I am not using those tools right now, but I encourage you to do so. Okay, and at this time, we're about to flash the code onto the board. And so make sure that your board is plugged in to your computer. Cargo run will build it and flash it to the device. Now that I've made sure that my device is being passed through to my virtual machine, let's try flashing that again. If you get a permission denied error while trying to flash your project to your board, it's possible that your user is not in the dial out group. After adding our user to the dial out group, let's try it again. After adding yourself to the dial out group, you need to log out and log back in. All right, this one is for all the marbles. All right. There you have it, folks. We programmed the ESP32 using Rust. The combination of Wi-Fi and Bluetooth on this small, inexpensive, very powerful board make this a monster of IoT development. There are so many cool things we could do with this. And using Rust for the software gives me a lot of confidence that when I ship my build out into the world, it probably won't break. I hope you all enjoyed watching this video as much as I enjoyed making it. I'm going to be integrating more components in future videos and combining them to do some pretty interesting things. Please like and subscribe for more videos like this. Also, if you're building along, please let me know in the comments. I would love to hear about what you guys are working on. Thanks for watching. See you next time.